Okay, so I'm just going to run through a quick example problem on using arrays, cover summations, and also I'll do the a problem on integer programming as well. So first of all, I'm going to open up just a text document. I just opened up Notepad++. This one has the APM syntax highlighting. If you want to go and get the syntax highlighting, just go here to the documentation, and under download, just go to APM editor, and it will show you how to download Notepad++ and the syntax highlighting. So when
I use Notepad++ already, but I'll definitely download the syntax highlighting.
Okay, great. So let me go ahead and just first of all start off with model and then an end model, and you'll see there's no syntax highlighting. But when I save it, for example, as a new model.apm, model can be anything you want, then the syntax highlighting appears, and that will be a little bit easier to see some of these sections that I'll define within APM. So I've got the model, end model, and then I'm going to do a parameters, end parameters. So parameters, end parameters, you already know what those are. They're fixed inputs to your model that can be changed either by data or by the user. So in this case, I'm just going to put a new parameter that's going to be m equals 5, for example. But then another one is constants. Okay, so constant section, and then end constants. When you get the keywords right, if you misspell them, the syntax highlighting will go away. I'm going to make a new one, n equals, for example, 20. 20 here, parameters 5, and then a variable section and end variables. Okay, so I'm going to have an variable x. I'm going to give it a new initial value of 5, and I can also just leave off that initial value if I want to not give it an initialization. Okay, now there's also an intermediates section with end intermediates. Okay, and in this one I'm going to sum up some of my parameters. Let me do this. I'm going to also put a1 to n equals 1. Okay, so all of my a values, I just defined a 1 through 20 because my constants was equal to 20 here. If I want to do a double index 1 to m, I just put a second semicolon there, or a second colon there. I'd have to move my m up into my constant section in order to be able to do that, in order to be able to use these variables within the arrays. Okay, but
the double colon means that's like the first one is the rows and the second one is the columns.
Yeah, that's right, and you could do a third one as well. You'll get multi-dimensional. P equals 2. Let me make this a little bit smaller because it's going to become very large. But there's my A, the N, M, and P, three-dimensional matrix there. Just for the sake of this problem, though, I'm going to reduce it back down to just the N, and then maybe just have 15 of those just for display purposes. Okay, so I've got some constants, parameters. Now let's say I want to sum up, these A parameters. Okay, so let me do S. I'll start with S0. I'm just going to do S0, defining that as 0. So that's the start of my summation, and then I can do S1 to N, S0 to N minus 1, plus A1 to N. So I'm summing up all of my A values with these two lines, and then the summation of all my A values is going to be equal to Sn. Okay, so I'm just going to give a new variable y, and then down in the equation section.
Let me ask, does this generate a running total?
Yeah, it'll generate. It'll generate a summation of everything within A. What do you mean by running total?
Well, if you if A were 1, 2, 3, would S be 1, 3, 6?
Yes, it would. Yeah, that's right. So
Okay,
it would,
now I see what's going on.
okay, so yeah, I'm starting with, this essentially is the same thing as doing S1 equals S0 plus A1, and then S2 equals S1 plus A2, and then I have S1 to N, 2 to N minus 1.
Yeah.
So I can continue it that way.
Now I understand how it works. That's good.
Okay, good. Okay, and then I'm going to, just in the equations section, I'm going to create a new equations with end equations, and then y equals s, and it'll just be the summation of that. And then I'm going to also have a minimize, let's say I have a minimize x minus a, or x minus y squared. Okay, so there I have one equation, one objective, which is the summation of those. X doesn't have bounds, so if I minimize the x minus y, x and y are going to be equal in that case. Okay, so let me go ahead and just solve. Let me go ahead and just solve this one first. What I'll do is I'll just go ahead and copy this. I can do this through the MATLAB or Python scripts, or I can just plug it into the web interface as well. Just replace the contents there with what I had set up, and then click solve. If I click this, it'll bring me down to the solution area. And it says index range for first vector, okay, is not equal to the index range for the third vector. So I forgot to change this to 3 to n as well. So there's an array problem there. Let me just change that. Okay, and then I'm going to come back to here and come up to the top. Okay, and just go ahead and paste that in again, and then solve it. Okay, so if I come down, just one degree, 2 variables, 1 degree of freedom, and that is, I'm going to click View Solution. Okay, and in this case, I see all of my intermediate values. Here are my constants here. Okay, then my intermediates S0. Let's see, that's going to be S0 through S15. There's my summation there, and then my A values. Those are all my parameters, and then here's my X value and my Y value, and those are equal. Okay, so let's say we also had, we wanted to feed in different A values as well. You have a model file, but you can also have a data file. And so the model file is your APM file. The data file is going to be a CSV file that you can. So let me get my model.
Separated values.
Yeah, they're comma separated values. That's exactly right. And let's see, where did I save this file? Save as. Okay, so I just saved it model.apm. Okay, so I have my model file here, and then I can create a new CSV file just by opening up, for example, Microsoft Excel, and make this a little bit smaller. Okay, so here's Excel, and I have A1, and I can give it a value. Let's say that's going to equal 1, and then A2. And let's say I want to generate these automatically, for example, in Excel. I can just fill this down to, I had 15, I think. So I want to generate this from strings, just putting strings together. I've got to use the double quotes on that, the double quote marks. I do the ampersand, and then I can construct it this way for A2 through A15. Okay, just double click on that black square down in the bottom right hand corner, and it'll fill down for me. Okay, so then I can put in numbers here. Okay, now in this case I've got to copy these and paste them as values. because otherwise it's going to change these when I fill down the random number generator. Okay, so here I have some random numbers from A1 through A15. And now when I save this, it's going to ask me, just the Control S there, or I can click Save, what type I want to save it as. In this case, I'll just do a comma delimited. There's some other ones that are CSV as well, like Macintosh or MS-DOS. The Macintosh puts some, it does the different line return characters. The one that works best is just this comma delimited one here.
Yeah, it's basically Unix, and Unix has a different carriage return.
That's right. Yeah. And so in this case, I'm just going to create this one also as model.csv. And it'll ask me if I want to, it doesn't support worksheets contain multiple sheets. Go ahead and click OK. And it says there's some features that are not compatible with CSV or comma delimited. Are you sure? Yes. Okay, so it's saved at this point, and then if you click, if you close it, it's going to ask you if you want to save it again. You can click Don't Save. It's already been saved. Okay, so let me go ahead and grab that CSV file here, and I'll go ahead and just edit it in Notepad just by dragging that in there, and then you can see A1 through A15. This can also be used to initialize values of X, for example. Let's say you want to give it new initial values. It'll overwrite what was in the model file and give it new initial values if you want to also initialize any variable or parameter that you want. Okay, so this is your CSV file. You can either load it, you can either load it through a Python or MATLAB with the CSV underbar load function. Here's a quick way to do it just from the web interface as well. I'm just going to come to my model file, and then I'm going to create a file, star.csv. The star.csv, that just says name it the same thing as my model file. Okay, when it's on the server, and then I'll just paste that in there. Okay, so there's my model file, and then I've just included my data file in here just as comma separated values inside my model file. Normally those two would be separate. Okay, and then I'm going to come back here to my my web interface, and then I pasted it in. Okay, and then I'm going to go ahead and click Optimize, and then when I view the solution, you'll see that now my summation is different, and also my A values, they're also different. In this case, let me just make it a little bit larger so it's a little bit easier to see. So my A values are all different. Those came from the CSV file instead. Okay, and then there's my value of X and Y. The same thing. The same thing applies to the variables. You can set those up. Let's say I had X 1 to N. Okay, I'm going to initialize those as the value of 5, and then in my objective function, I can also put, in my equation section, I can also index these, by creating a vector here with X. And this actually is going to be a combination of n objective functions. So it's basically the sum of these squares. Okay. So now X is going to take on a different value for every value of A as well. Let me put the A's in there. Okay, just to show that. And then Y is not going to enter into the objective function. But I could do something like also combine these, let's say xn minus y squared. So in this case, I'm going to maximize that. So I have two objective functions here. Well, actually, 15 objective functions here, and then one more objective function there. I'm just combining those into one optimization problem. So let me go ahead and take this, and I'll solve it. Okay, so I'll just go ahead and paste that in again, and then optimize. Okay, so let me just check and make sure this completed successfully. Okay, so that it actually did not complete successfully. It went up to 100 iterations, the objective function got quite large. This might be an unbounded solution, for example, okay, because I had a maximize function in there. Let me go back to this. I'm going to just change this to minimize. Okay, and then back to my web interface. Okay, and I can select a different solver as well. If one isn't working, I can select a different one. I can also click try all and try all the different solvers. In this case, I'll select APOP and then go down to my solution, and let's go ahead and see if this one solved a little bit better. So 16 state variables, 15 degrees of freedom. I had one equation in there. So 3 iterations took 0.03 seconds, and there's a value of my objective function. Okay, so let me look at my solution as well. I'll scroll down and see my value of y. Each x value now has a different different value. This is equal to a. Just the last one is different because I also y is going to influence. I had a sum of squares for that as well. Okay, so does that make sense, or any questions about that?
I'm a little puzzled by having a minimize and a maximize, or even two minimizes in the same problem.
Okay.
What do you have more than one objective function? What's it doing?
Okay, so that's kind of like, let me go ahead and just comment these out. I'll comment that one as well. So it's kind of like having, this objective. This is just one, and then I would be adding x1.
Okay, you're just adding them together.
Minus, let me put a parenthesis there, x1 minus a1 squared plus. Okay, so you get the picture there.
You're not doing multi-objective programming.
That's right. In this case, it's just a continuation of the summing up all these squares.
Okay.
You can do multi-objective, but that's probably a topic for another time. Okay, so the last thing I wanted to show is just how to do integer programming as well. So if one of these values, for example, y, has, or let's say x. Let me just remove the x's here, the x1 to n. I'll come back to what we had before. X minus y squared. Okay, so I'm going to minimize that difference. The summation equals y. And then I say that x has to be an integer, so I do that just by prefacing it with int. So any variable that has int at the beginning, that's going to be an integer variable.
Can you also specify a Boolean variable?
The Boolean variable, you just do int x, and then just say that it's less than or equal to 1, greater than or equal to 0. Okay.
Okay.
So that'd be one way of doing it. Okay, so let me go ahead and I'll just say 5. Let's see. Let me go ahead and bound this 50 to 0. In this case, it's just going to sum up those values.
Why do you have int underscore x?
You could do int x as well, just like that. Let me go ahead and just do int x in this case. I think that'll be okay. And then let's say you've developed a model, but you don't want to use int in your model. You can also just take and define a new intermediate, which is just x equals int x. Okay, so then you can use x down here in your equation section without having to include the int. Okay, so let me go ahead and transfer that over as well. I'm just going to refresh this page just because that last problem was a little bit big on the text box. Okay, so it'll expand to fill your problem there. So now we have intx. The tabs just here didn't, the tabs versus the spaces. It makes sometimes your problem not as pretty as it could be. So when you just paste it in. Okay, now the only one that'll do MINLP currently is APOP solver. IPOP will just do a relaxed NLP, considering all your variables as continuous. APOP will do the that'll do the integer programming as well. Okay, so I'm going to come down here and then let's take a look at our MINLP. And so it took 3 iterations, successful. There was the time. And then let's take a look at our values for that. So if I come down to INTX, the best solution was 5. You can see the value of y was 5.49. Okay, so if that would have been 5.51, then this probably would have been 6. Okay, but because it was just under that, the minimum solution was equal to 5. Okay, so that is covered a couple different things here. Let me just go ahead and summarize. The first thing is constants. You can declare constants and then use those to define your arrays or matrices. We covered summations as well. Okay, so this is one way to do summations. If I just want to do it in 2 lines, I can do it just like this. Okay, so there's a summation that's going to sum up.
You can do a product that way too, and changing the plus to times.
Yeah, you could do a product as well. That's right.
With 1. Yeah, I mean, S of 0 would be 1, I guess.
Yeah, that's right. So there's your product instead of the summation. Yeah, good point there. And then we also covered how to declare integer variables, just adding the int to the beginning. You can do a binary variable, just doing it between 0 and 1. I redefined a variable here just in the intermediate section. The intermediates are kind of like equations. A lot of times I like to move them down after I've declared all my parameters and variables. It doesn't matter though. Intermediates will be updated with every function call of the model. Okay, and then that substitutes those values down into the equation section. So in this case, x and then Sn are both substituted down there. Sn being the summation of all of our a's. And then we also covered how to define objective functions. You can do a combination of minimize and maximize functions there as well. And the final thing we covered was how to include data files. Okay, so you can update parameters or variables with a data file, and just including them as a comma separated values.